you very much indeed. And can you see the first photograph? Right. Good morning, everyone, and thanks for joining. Normally, I start off by going straight into the failures, but this one I'm going to give a little bit of a lead-in on the construction kind of what the steps of construction. And the first one I've shown on the slide here is when the geotechnical work is done. So I'm taking a building now, and I'm going right back to when we start. So the first thing they do is they appoint a geotechnical engineer. A geotechnical engineer will go out to site, and as you see on the slide here, they take cores. They drill into the ground, and they extract cores from the ground. And from those cores, they can establish what kind of material you're going to be constructing on. That then allows the engineer to design his foundations. If it's very soft material, very hard material, how deep he has to go, etc. So the geotechnical engineer is extremely important in the first phase of a construction project. So you'll have this core drilling machine on site. I'll then go to the next slide. It's either going back, you either do a core, which is taking these cores, or you do a excavation and you then map. You do an excavation, you then go into that hole and you map the material in that hole. And all this information is given to the engineer, who's then going to do the design of the foundations. The next slide I'm going to show you, if you remember the core drilling, this is what is extracted from the ground. And it's laid out in what we call a core box. So these cores, this material is laid out and allows the geotechnical engineer and the engineer to look at the material. Depending on how deep you're going to go, if you're going to do a lot of foundation work, a lot of basement work, then you may go fairly deep. If you're doing a shallow foundations, it may not be that deep. Again, depends on what you find. If you look on the left-hand side here on these cores, that is a very friable material. It's a clay type material. You can't found on that kind of material. If you look on the right-hand side, certainly in the center there, very competent material, which could in fact take a building. But then what happens, they've broken through that material, and underlying that hard material again is soft material. So one has to be very careful when you reach hard material to say, oh, that's good enough. You've got to go quite deep to understand what your underlying material in fact composes of. And certainly in places like Durban, etc., which has very variable soils, you may go fairly deep to establish your foundation conditions. Once you've established your foundation condition, this what you call geotechnical report is given to the engineers and clients. You then go ahead with your design of your foundations. What would normally happen, certainly in a place like Durban and certainly Johannesburg, is that if the ground is loose, the ground is not competent, what you do from ground level, you'll put these, what we call soldier piles, you'll put these piles into the ground, and this will then support the sides of the excavation, and also, very importantly, support the adjacent properties. Lateral support, we have a lot of claims on lateral support, where support is removed from the adjacent property. And on lateral support, in fact, is strict liability. You're not allowed to affect the adjacent property. So any damage to the adjacent property is strict liability. You are liable. So you would put these piles into the ground and then remove the ground inside the piles. If you're going fairly deep, what you try to do is then anchor these piles into the ground. And what you do then is you put cables through the pile. So you drill holes through the pile and into the ground. Normally a length of about 14 or 15 meters, you put these cables into the ground and you then tension those cables using a hydraulic jack. That then supports these piles. So if you're going 2 or 3 basements down, you would want to support these piles with these anchors. Those anchors then put into the ground and stressed with a hydraulic jack. In some cases, you can leave those anchors in the ground if there's nothing adjacent. If you own the property adjacent to where you're building, or is something, it's a park, or it's not going to affect any other property. In many cases, you've got to remove those or detension those cables when you finish the construction work, because you're imposing on another person's property. Obviously, before you put the anchors, you must go to the adjacent property, to the engineers, whoever adjacent to you, and say this is what you're going to do, get permission to put those anchors in the ground, and then reach an agreement how long before you have to remove them. So here's placing the cables through those holes you just drilled. You put those cables through those piles, and you then have the jack, which you see in front of you. We're in the middle of the picture. That is the hydraulic jack, which will then tension those cables and support those piles. Once those are supported, once you've got your lateral support in place, you then take a piling rig into the basement and you put these piles. You see these collection of piles here, and the piling rig is on your left-hand side there. These piles then support the building. So the piles either go down to what we call refusal, which is down to very hard or rock material, or they're friction piles, which in fact depend on the friction between the ground and the pile, if there is no rock or very competent material present. So you have to work out the amount of friction you need on the pile, the diameter of the pile, the loads from the building, and work out exactly what length of pile you need to put in and the size of pile. And what would normally happen is the engineers say, I need so much kilonewton load to be imposed on that pile. The piling contractor would then design the piles and implement that operation of putting these piles in place. So these are set out normally for the building I'm going to show you, which is in distress at the moment, my first failure. You normally put these piles under the columns which support the parkade. And I'll show you the next pile. What happens then, once those piles are in place, they're trimmed off. So you have those piles now projecting above the ground. You come in, you trim those off to a common level, and you put in what you call a pile cap, which is this concrete square block you see here. That is placed on top of that pile. Once that pile cap is in place, the column is then start to be constructed. And you see the slightly smaller block, which in fact is the column for the parquet, for the basement parking. So that is how, coming from the ground up. So I'll go to the next slide. This is then what the parquet would look like. You have all these columns are now supported on the piles. And bear in mind now, whatever you put above this, whatever you put above this parquet, whatever you do with the building, the load has got to come back down through these columns, back down to those piles. Those piles are supporting the building. You can't put loads where you want to put it. They've got to come back to these columns. So that is, this is now going on to this is still a parquet. So these again will be supported on piles. And then what would then happen is once you got to the ground floor, your layout of your piling, your columns, you don't want to make it look like a parquet. Otherwise, you walk into a building, looks like you're walking into a parking garage. So your set out of your columns are different to the set out of columns in the parquet. So to transfer the load from the building above the parquet, you put in what you call a transfer slab. And you see it there. There's a thick one and there's a thin one. So what happens though, those transfer slab over those parquet columns, you can put any load above and any spacing of columns you want above that. That would then transfer the load from the building down through those columns and down into the piles. So that is how you do a basic engineering study of how you do a building. I'll show you more. It's another transfer slab. Here you can see the parquet below. There you can see the piles and the pile caps. You can see those two-level parquet. And then a very thick concrete slab, which you see there, and that is your transfer slab. And you can see the columns above the transfer slab are not above the columns in the parquet. They are at different positions. And by doing that slab, you transfer the load down through those columns and into the piles. Here you can see it very clearly. This is a building, a high-rise apartment. And again, you can see there's only one or two columns and a very heavy transfer slab. You can see that just below the apartment building. Very heavy transfer slab, and that is transferring the loads. Once you get above the ground floor and into the building itself, you don't want to put in this very heavy transfer slab. what you then do is transfer beams. So where you have a column which is not directly above the columns below, you'll put in what you call the transfer beams. So you can see here on the right-hand side, the kind of middle one, this is a composite transfer beam. It's taking a column which is not above the other columns and transferring the loads across. Now, where we had the failure on this particular building, and I can't give you the kind of values at this stage, this is very much an ongoing investigation. Here, again, it's transfer beam, and you see it's transferring the load from that green down to the green ones below. This is the building we're involved at the moment. This is a 7-story apartment building. At the moment, you can see there's 4 floors up there, and below the ground here, there are 2 parking garages. And what's happened here is that the design of the transfer slab and the design of the transfer beams is incorrect. So what we're having to do now with this building, initially, we have supported the entire building inside the parkade. So both levels of parkade are supported now on these very heavy duty jacks. So going back, this is, you can see here, there's another building in front of you with a lift shaft, and this is back underground. So these are the big jacks or props we put in to support the slabs. I think I have another one, very, very heavy duty props here. And this is supporting the building at the moment. So what we're having to do now is to design the building to take over the failure of these transfer beams. So they've come up with the solution now is we are going to put additional steel columns in place. But to do that, again, I told you, you've got to go down through those. This is one of the columns, one of the power caps. Because we're going to be placing those steel columns at different positions, we're having to put new transfer beams underground, which you see here. And these transfer beams will span between the columns, which will then allow us to put new steel columns in place.
Martin?
Anytime.
If I can interrupt you quickly,
Anytime.
I'm not sure if this is relevant for this
Please.
particular incident, but how reliable is the use of AI tools when it comes to engineering? So whether it is to maybe, formulate a report on the structure of such a building, what comments do you have and what trends have you seen in the AI space and engineering space?
Not at this stage. We have programs which we've had design programs, for instance, Revit or any of these programs. These programs are in place, but AI does not do the design. We have design programs which do the design at the moment. We have CAD programs and design programs. AI has not got into there. It may well do going forward, but not at this point. We have design programs. The only problem with the program, and we've said it many, many times, it's rubbish in, rubbish out. The program is not at fault. It's what you put into the program. So if you put bad data in, you're going to get bad data out. And in many of our cases, the engineer accepts what comes out of the program, not realizing or not noting that, in fact, he's put bad data in. So it's really the data you've got to check, not the program. It's the data that's going into that program. And again, I say it's rubbish in, it's rubbish out. So in this particular case, the data was put into the program was incorrect. So the program was fine. The program did what it needed to do and gave the results. But it gave the results based on bad data. So the results are wrong.
100%. Thanks, Martin.
We've had this many cases.
Thanks, Martin.
No trouble. So these are some of the new steel columns we're putting into the building. And what will happen in these steel columns then are put in, this is the upper basement parking. And same thing will be underneath these two additional columns underneath. And then those will go down to these new ground beams, which you saw just now. So that is how this building is going to be supported. What's going to happen now, they're going to put some concrete around these to kind of make them look more aesthetically pleasing, so they'll match in what's there. But the problem now is we've lost 54 parking bays. So what will happen now is there's one building still to construct. So what they're going to do on the last building is put in a further parkade. So instead of having 2 parkades, they'll have 3 levels of parking to supplement what in fact we'll be losing here by putting these additional steel columns in place. So this is very much an ongoing investigation at the moment. I'm not going to the ramifications of how you transfer the load to these columns. That will be a separate seminar, will take some hours. So these are going to be in place. These are going to take the load somehow, transfer the load to these steel columns, and they will carry then part of that building, which the transfer beams are not carrying at the moment. So that is our first exercise. That's our first one. Very much ongoing, lots of discussion, lots of meeting on this one. Those are the steel columns again, and the props are still in place. They'll slowly be removed, and these steel columns will then take the load. This is one which is up north in one of the African countries, and this is a hydroelectric scheme, and this is an argument as far as temporary works are concerned. They put in temporary works for a 1 in 5 year return period, and when they got a 1 in 100, it washed it all away. You can well imagine, and it caused a lot of damage to the works under construction at the time. And that all had to be replaced. Where we had a problem, and I'm getting out to the brokers at the moment, what happened with this particular policy is that they gave the cover from whatever African country, and I'm not going to give the name at the moment, and then it had to be reinsured by the broker. What happened here, the broker failed to reinsure. So this ended up as a PI claim against the broker, because the broker failed to do his job. So they only had 5% of whatever cover, 5 or 7% cover from the lead insurer, but they had no reinsurance on this policy.
Martin,
so yes.
Sorry to interrupt. We quickly.
No, please interrupt.
The question is from Dominique Mongus, asking how did they establish that the foundations were incorrect?
The foundation was not incorrect. I'm going back now. What happens? What you see there are the beams above, and in some cases, those are what you call transfer beams. When they had, and I go right back, when they had constructed 4 levels of the 7 levels, some of these transfer beams started to crack. They started to fail. And if you don't have the full load of the building on, and beams are already cracking, then you know you have a problem. And that is why they stopped all work. They didn't know what the problem was at the time. They stopped all construction work, and they started bringing all these props in to hold the building up until they established where the fault was. It took them something like 4 weeks to establish exactly where the fault was. So in the interim, they brought all these props in. Yes, so how do we know the failure? These beams started to crack.
Noted. Thank you.
Thanks.
Please ask questions as we go. Please. Okay, so this was a twofold one. So here, the broker failed to reinsure. And then what happened, they took out the new policy. The new policy was put in place, and we had a second flood. And the second flood, the contractor failed to do the upgraded temporary works, and the claim was rejected. So this really was almost like a comedy of errors on this particular matter. First, there was no insurance, and the second one, that the contractor failed to do what he was told to do by the second insurer. We have a lot. This is what you call an ash dam. I think this particular one is down at Sassel, and we have a lot of problems with these ash dams, is the protection of these ash dams. And you see these, what you're looking there, the darker material, in fact, is plastic, and which is laid out. Before you lay the plastic, you put under plastic drainage, and that then takes the water away, and you capture that water in a pond. But then you put this plastic liner right over this dam, and you seal that plastic liner. But during the laying of this liner, it is very susceptible to wind damage. So you've got to try to keep this liner, this plastic liner, down. We have many cases where, in fact, the wind gets underneath it and blows it all over the place. And it's very, very hard to recover that plastic. It kinks. It's quite thick plastic. It's what's called an HDPE plastic. It kinks, it buckles, and you can't recover it. And you then have to cut and throw it away. You can see here, you can see the areas of plastic, liner this down, big areas still to be laid. And when you get a windstorm, that plastic liner is blown all over the place. And on this particular matter, I think we put something like 5 million rands worth of plastic back again. We couldn't recover it. This one is a bit closer to home. This is in Johannesburg, and this was Bree Street. And Bree Street had an explosion and damage. I don't know whether you've got a view looking down Bree Street. Yes, we have. Looking down Bree Street, a lot of damage on this road. I think there was one fatality where a taxi went up in the air. And during the investigation, initially our client was held liable, which was Egoli Gas. They said it was a gas explosion. We did a lot of investigation on this matter. And if you look on the right-hand side there, that kind of hole there, that is an underground culvert. It's like a box you can walk through. And inside that box are all the various services, such as water, such as cabling, etc., etc. By the way, there's no gas line in that culvert. And what happened over some period, and we're not sure, this culvert was put in 1937, all a long time ago. And at some time during its lifetime, they broke through from the culvert to a sewer line underneath. And I think the idea was any buildup of water in that culvert drain off into the sewer line. But the problem with sewer lines, they have methane. And over the time, methane percolates up and fills this culvert. Again, there wasn't a problem. The culvert was aerating, it was ventilating through the manholes. But because of cable theft, the manholes were then welded down. So then there was no escape for the methane. The methane built up and there was an electrical spark and went bang. So this, in fact, was a methane explosion. It wasn't a gas explosion per se. It wasn't a gas explosion from Egoli Gas. But it caused a huge amount of damage, as you see. I understand from the latest kind of press releases that the council has allocated a certain amount of money to rebuild Bree Street, I think, which is a major taxi route. My own feeling is I think you should just turn it into a pedestrian walkway. And I say that because look at the amount of services in the ground. Now, each of these services has to be tested to see if they're live. If they are live, you then have to establish from where and to where they're going. You then have to reroute that service and then move on to the next service. I think it's just easier to turn this into a pedestrian way, but that's not my decision. The council, by the look of it, is putting the road back. But it's going to take an awful long time. I think their initial estimate was 2 years, and that was 2 years from a year ago. So I think it's going to be some time before Bree Street is re-established. That was one that we've broken that manhole open. That was one of the manholes which was welded down to stop cable theft. This was down near Grahamstown. This is where they're widening an existing highway. And the existing road is the one you see in front of you. On the right-hand side, they were meant to blast a part of a small copy away to widen the road. But instead of blasting the material to the right-hand side, they blasted the material straight over the highway, straight over the existing highway. There was lots of discussion whether this was third-party property, etc., etc. And eventually the insurers agreed that it was surrounding property because they closed the road to do the blasting. So they paid under surrounding property extension to the CAR policy. So what we had to do was take all this material away. And unfortunately, the road was severely damaged. As you see, we're taking the material away there now. We then had to take up the whole road, which was damaged, and redo all the layer works, and then put that road back again. So it took some time. There was a lot of disquiet from the locals. We reduced down to 1 lane while we repaired the second lane, and then we repaired the second lane. So it was done in half widths. That's it, just before we're putting the final base course on and the final premix going on. This is a pedestrian bridge in Johannesburg, which spans the river that runs through Alex, hence the Yexgang River. And what happens with this pedestrian bridge? It's a steel bridge, a steel arch bridge, supported on two concrete abutments and with a concrete deck. At the time of the event, the abutments were cast, the steel bridge was in place, and they were cast in the concrete deck from one side, being cast here from the left-hand side going across. When they got about a third way across the concrete deck, the whole bridge buckled. And they immediately stopped pouring the concrete. Then they started to check the design. In the meantime, they demolished the concrete, but the bridge was badly distorted. I think I have a picture of the... Okay, so this is the one end. This is the one concrete abutment on which the arch is supported, the steel arch is supported. And where the error was here was that the arch was supported on bolts and it was not grouted. So in fact, the bolts were supporting the weight instead of the actual concrete supporting the weight. Someone didn't do the grouting, and again, that's under discussion at the moment, who's at fault, but the grouting was not done. At the moment, our engineer is being held liable under a PI policy. You can see it's badly deformed. We still believe the arch is competent. There's nothing wrong with the arch itself. It's just this deck has to be removed and replaced. And then we've taken the concrete, we've taken the weight away in the new design, and we're putting a lightweight timber decking across this bridge. So that is the redesign. At the moment, the bridge looks like that at the moment. No remedial work has been done. There was a lot of argument. The client wanted that whole bridge taken away and taken back to the manufacturers for checking. And we believe it can be checked in place. And as I say, just to remove that deck and replace the deck. So that is still under discussion. We hope to resolve this in the next couple of weeks and leave that arch there and just replace this deck. So that is under discussion at the moment. And also under discussion, who was responsible for ensuring that the grouting was put in place? Was that a contractor's responsibility or was it an engineer's responsibility? So at the moment, that's still, again, still under discussion, and that part has not been resolved, who's at fault. That is the base plate, that's where it's going down, and they put temporary, the one on the right-hand side is a temporary block, so there's no further movement of the arch. But in due course, that will have to be grouted up correctly. I put this, it's not a large claim, but it's an interesting claim. This is a church, I think it's down in Port Elizabeth or somewhere like that. This is a church. Part of the new work was putting up this steeple you see on the right-hand side there. The other major change they wanted to make, and I think I have, no. Okay. The other one they wanted to do, there was an opening through the gable end wall of the building. The church approached to the architect, and the architect said you can widen that opening, but you'll have to support that brickwork which you see in front of you there. So the engineer, our engineer, came up with a design of putting in a steel truss. So the steel truss will go behind that wall so you didn't see it. So as we're sitting now, that steel truss is sitting behind that wall. And that steel truss will then take the load of a span of about 13 meters, will take the load of the brickwork. So the steel truss was put in place, some temporary props were put there, and then they took the wall away. There was 2 steel columns put in place to hold up this steel truss. So they then took the brickwork away below this truss. The problem being is there was no load on that truss before they demolished the brickwork. Because you can't get load on that truss, that brickwork has to fail before any load comes on that truss. Unless you jack that truss up, there is no way you can get load onto it. And that's exactly what happened. As they removed the brickwork above started to fail. It started to crack. And that's what we would expect, because then load slowly comes onto the steel truss. Sorry, you want to ask a question?
Sorry, Martin. I think I'm going to have to cut you off because of time. I'm going to introduce our next speaker, David.
Oh, is that me finished? All right.
Yes, I'm so sorry. I know we can go on ages and ages. So
there's only another 80, so don't worry about that. That's fine.
So our next speaker is David Check. I hope I'm doing justice to your surname. So David is a partner at Cox Yates up in Durban. He obtained his ILB summa cum laude at the University of Natal. He specializes in insurance litigation and infrastructure law. His experience ranges from public liability to professional indemnity claims, construction claims as well, loss of support, collapses, and the like. So I think David's presentation is mainly focused more on the legalities, of insurance contracts and how the important aspects of the contracts, the role players, the risk associated with the role players. He'll also give us some claims examples on that. So without further ado, I'll hand the stage over to you, David. Thank you.
Thank you so much, everyone. I hope you can hear me. And I hope there isn't feedback because there's a second sound source in here. Okay, you have to switch that off. You have to move that. That's fine. Okay, so once we just mute the sound source. Okay, so we'll no. Should we try again? No, there's still feedback. It'll be killing people with earphones. Okay. Is that better?
Lucia?
No. Can we take the laptop outside?
Yeah, I think Lucia can mute
okay,
her speakers.
There we go.
Yeah.
Okay, so I hope you can see my slides. Right. So I normally give this talk over an hour and a half, and I apparently only have 25 minutes. So if you just bear with me, we may have to do this faster than I would like. So I think let's start off with Martin's giving you a fantastic background into how structures are constructed, the planning and the phases that they go through. My talk is more on how the negligence occurs and where it arises and why it arises. As a consequence, you can imagine this talk could be given over a full day. It is a very, very, very interesting section because there are a number of sources for negligence in the construction industry. And when there is a major calamity or collapse or casualty, there are a number of investigations that take place. And this is going to be like a speed dating flirt on a lot of those because we won't be able to go into them in too much detail. Right. In order to understand how it arises, you've got to understand who the industry role players are and what they do. So, of course, you have various different engineers that play different roles on site. You may have a resident engineer or RE who sits on site all day and supervises the works. You may have a design engineer who actually designs the structure to be constructed. You then may have professional architects in the background who have helped design and draw. You'll then have professional quantity surveyors. You have geologists or geotechnical engineers, technologists, accountants, lawyers. Okay. One thing that you also need to understand is deal flow. And by deal flow, I mean the following. How does a structure come to be constructed? Well, you have an end user client. That client wants, for example, a large warehouse to be constructed, and the large warehouse has to have office accommodation in it as well. That client will traditionally go to a consultant engineer or a consulting engineer, and that consulting engineer will do the engineering drawings with an architect and a quantity surveyor. They'll produce the bills of quantities, the designs, the plans, the drawings. That will then go out to a number of construction companies who will price on it. The construction company or the contractor will then build it. The contractor will be supervised by the engineer, the QS, and the architect. The contractor or construction company will then subcontract to subcontractors. So if you just look at professional indemnity aspects that can arise in that deal flow, there are a number of areas where a professional, not just the engineer, quantity surveyor, architect, engineer, can get it wrong. And also, you've got to look at design obligations, supervision obligations, inspection obligations, because for me, those are the three biggest areas. And a new area that's come up a lot in the last year in claims is contract administration here. So, for example, the engineer is appointed as the engineer under a FITIC contract, or the engineer or the quantity surveyor is appointed as the principal agent. So, just one second. So if we just look at this, relations on and off site, what are the relationships? So the employer, as I've explained earlier, employs the main contractor and direct contractors, also employs the resident engineer and architect. The employer can employ the design engineer, and then the contractor can contractually agree to design. So this is where EPC contracting comes in. And again, I sadly only have 25 minutes. But the design doesn't necessarily come from the employer. I may want a large warehouse, and I may, as the employer, and I may go out to market and look for people to build my large warehouse. I may go to an engineer and say, please design it for me. The other option I have as the employer is going out to market and saying to the market, I don't want to design this thing. I don't want any liability. I want to EPC contract. So basically, I want to bring a contractor on who has their own in-house design engineers, or alternatively employs a subcontract engineer. I want you to design it. I want you to be responsible. All I'm going to tell you are the categories that I want you to achieve. And all of that risk then gets passed to the contractor. So that is how the contractor may also have design risk if it's an EPC type contract. So why is there contractual dominance in the construction industry? Sorry, I'm just plugging in some power. Basically, it's high risk, high value. There is always a professional negligence component. So the professionals get appointed in terms of PROXA, FITIC White Book, NEC3, one of the suites, or NEC4. Tender-based appointments in the public sector. As you know, the government is the largest contractor in our country. And in terms of all the procurement legislation and requirements that the government has to procure by way of contract, you also have the built environment space being dominated by 4 major contracts, JBCC, GCC, FITIC, and NEC3. You sadly today, and in representing engineers before the Engineering Council a lot at the moment, and the engineers have still not learned that cigarette box type contracting is massive risk. So they are still contracting poorly. They are still not signing proper PROXA or consultant-based contracts. They are still accepting these 2-page appointments that don't deal with insurance, don't deal with liability, and that's actually still a thing, despite the fact that it's 2024. So risks, and again, apologies for the speed, but time is precious. As you can imagine on any construction project, and I speak project-wide, not just construction-wide, as you can imagine, there's always financial pressure on a project. I would say most projects fail or come into some form of difficulty because finances are tight. There's always shortcuts to be taken, and time has a cost attached to it. Employer input inadequate. Let me tell you, there are so many projects where the engineer gets blamed, and when you go back and you start to dissect what went wrong, you find the employer's input or the employer's specification where the employer designs is so poor that that is actually where the problem arises. Design, as Martin's touched earlier, lack of technology or human error in the design, and under design or design that is inadequate. Those are the terms we like to use. And, you know, Martin showed that Martin's first example, that is a structure that can't even take itself weight. You know, as the concrete's been poured and as the propping's been taken away, things have started to move, things have started to sag, and if it can't take its own self weight, and now remember, that is just the mass that is attracting the force of gravity that is pulling vertically down, that becomes weight, self weight. If the reinforcing steel and the support foundations can't even take self weight, that is a significant problem. Material, either an inferior material has been used or the testing has been wrong. So we've seen lots of construction and engineering failures where it goes straight back to material. Either the material put down as inferior or the testing has shown it to be fine, but it's actually inferior. There's a problem with testing. Construction workmanship, you know, the contractor always gets blamed. It's always that contractor. There are examples where construction workmanship is a problem. Poor supervision and inspection. Please, you must differentiate between supervision and inspection. They are not the same thing. In terms of the Engineering Professions Act and the regulations attendant to it, it clearly distinguishes between supervision and inspection. Supervision is your resident engineer that sits on site and actually watches what happens and inspects what happens closely. Inspection is completely different. That is where your design engineer pops onto site once every 2 or 3 weeks, walks around, looks at things generally, speaks to the contractor generally, and relies on the contractor to feed back information. And then, of course, expertise is a problem. Companies taking on projects where they just don't know, they don't have the expertise, they don't know what they're doing. So, for example, a lot of the bulk water woes that are happening around the country, that is an example of engineering firms taking on bulk water engineering projects, or contractors taking on bulk water engineering projects where they just don't have the expertise. They just don't know how to do the work. Okay. Okay. Now what happened? Yep.
Can I quickly ask a question? You touched on the contracts that are dominating. I just wanted to find out from you, how important is limitation of liability? And if this is included or catered for under all the contracts that you mentioned that are signed by the various engineers and the various contractors?
So I could speak to that probably for a day, because remember, you have the 4 main contracts that exist in this country. There's always a contract. So let's start there. People always say to me, oh, there's no contract between us. The second you are employed on a project as a professional and you are performing work for an employer who's paying you, there is a contract. And often you have, but I've signed nothing. That is irrelevant. There is a contract. It just means that you are a poor professional and you are negligent in the way you do business. So start there. There's always a contract. Number 2, your liability is governed by the terms of that contract. So what does your contract say? So if you have nothing in writing, well, what did the parties agree? Tacitly, in email? Is it partially written, partially oral? Is it a contract by conduct? So you've got to start there if it's not written. Strip out emails, strip out correspondence. What exists that can help me establish what the contract is? If it is one of the big 4, and by big 4, I mean FIDIC, GCC, NEC3, NEC4, and JBCC. Alternatively, MBSA, PROXA, one of those subordinate contracts that subordinate through the JBCC. Those contracts will have terms on liability, but remember, those terms can be amended through adjustments made in the appointment letters, adjustments made in the contract data, if it's a tender appointment. So the short answer to that, because time is short, is every single contract will have, sorry, there's feedback on someone's machine.
I'm going to mute myself.
No, it's fine. No, it's not you. We've worked out what it is. Every single contract will stipulate a different term on liability and set different liability parameters. So that's the short answer, is you've got to actually work out what the contract data says, what the adjustments or amendments are in the special conditions or Z clauses under NEC3 or particular conditions under FIDIC. You've got to get the contract data, strip it out, take a look, and actually see what it says. There is actually no one standard. And people often say, oh, but PROXA is the golden standard for engineering procurement. That's nonsense. That's just not the truth. PROXA is one that people often go to. The PROXA standard, I think, is 2 times the fee, but that is getting amended all the time. So that's not the standard. That's not the rule. Please don't believe that's the rule, because it's not. You've got to actually get the contract given to you. You've got to look at the contract data, look at the special conditions, particular conditions, because now more and more, especially under the FIDIC Sunrail contracts, for example, which are the big juicy ones being handed out at the moment, the main contractor is being asked to underwrite the performance of the employer's engineer, which for me is bizarre, but we'll leave it there. So you've got to treat it on a case-by-case basis, and you've really got to dig down and make sure you're looking at the entire contract. So I actually give a separate talk on what does each one of the major contracts say about liability and insurance, and I go through them, but that takes hours. And sadly, we've got 12 minutes. So that's the short answer to a very long one. So right, investigations I've been on that have taken years to complete. This is the Tongaat Mall collapse, where a post-tension concrete deck failed. That is what the deck of a shopping center looks like when it collapses. There you can see the concrete, all the steel, and the columns in the background. That's just a view from the top of the deck. When you stood on the deck, it actually felt like the entire structure was still moving. So it was quite a thing to be up there. It's another view from the top of the deck. That gives you an example of scale of just how big the collapse was. That's me standing on the deck, getting close to the edge, which of course nearly had the people from the Department of Labor having an emotional meltdown. You can see how the deck actually was it was a slip joint deck on the left edge, that L shape, how she just sat on there and held by friction. There's another view of some of the steel that was actually still in place, the propping that was still in place, that was being removed when this decided to fail. There gives you another view of scale. That's the little bucky that was on the top of the deck, parked on the top, that actually came down with it, and there's a mezzanine level in the background. Grayston Drive is another one. Here you can see the temporary works that failed over the N1. Sorry, I see someone's got their hand up. Somebody wants to ask a question. Anna, do you want to ask a question? I see you've got a hand raised. Okay, so I'm going to continue. I can't hear Anna. So Grayston Drive bridge collapse is something else I investigated. Here you can see the temporary works that collapsed. So that is scaffolding and supports. So it's not the bridge that failed, it's the scaffolding that actually collapsed onto the bridge, collapsed onto the N1. It was a terrible incident. That's what it looked like the day before. So you can see it's temporary works. So that's what temporary works looks like. Again, it's not the bridge, it's not the final structure. It is what's going to hold up the final structure. You can see how big the members are. And that is on the N1 after the collapse. So let's get down to business, sadly. One of your insureds are appointed to build a bridge. The bridge collapses. Sadly, workers on site are badly injured. Sadly, workers on site are killed. What happens at that minute? The dust is still settling. What potential liability can arise? It is literally a smorgasbord of liability. It is one of those charcuterie platters that arrive and you don't know what you're going to eat first because there's so much. It is a minefield. So, and I always said to people when I'm speaking to them after something has happened and we come on brief, you've immediately got to create subdivisions and you've got to be able to juggle. So remember, the South African Police Services immediately kick in because there's been deaths and injuries. The National Prosecuting Authority is potentially going to be involved. The South African Police Services always loiters in the background. Because you have registered professionals, the professional body, in this situation, EXA, the Engineering Council of South Africa, or the quantity surveyors or the architects' professional bodies get involved. They start their own investigation. They appoint one of their own and they start investigating their own. There are chances of deregistration and prosecution. Same thing happens to accountants and auditors. The really big one is the occupational health and safety investigation that happens in terms of the Act and the construction regulations of 2014. Okay, so what happens immediately upon a collapse where people are injured and die is Section 31 kicks in. Immediately under Section 31, an investigator is appointed, and the Department of Labor has a number of engineers that investigate. That investigator that minute can walk onto the site. They don't have to give you notice. You have to allow them onto site, and they immediately start investigating. They immediately ask for contracts and drawing, and they start taking statements, and they go at it. And it is incredibly invasive. You've got to move very quickly. You haven't had time to investigate yet, and you're immediately trying to back off questions. It happens very quickly. Your insured has to be warned of this immediately, and you've got to be on site with them collecting information, and you've got to run interference with the Department of Labor. I'm not saying obstruct the ends of justice and potentially get arrested, but you've got to give your insured space so that they don't implicate themselves on day one. Why is Section 31 so important? Because what happens is the investigator then drafts a report within the first month or so. If that report has prima facie evidence of a breach of the Occupational Health and Safety Act or the construction regulations, or putting someone in jeopardy or risk, immediately a Section 32 formal public inquiry commences. And it is a scary thing, because the public inquiry is a public inquiry in the true sense. If one happened for Tongaat Mall, one happened for Grayston Drive, one happened for Nyaka Dam, one happened for the Pretoria failure that happened recently. Two are on the go at the moment for two failures in an industrial park up here. Anyone can walk in, anyone can have their say. Now, of course, what you get is you get trial by TikTok and social media. You have all these wannabe sleuths sitting in the audience, tweeting and Xing, whatever you want to call it today, and it becomes a mess. And of course, people give evidence. That evidence you get cross-examined on that evidence. And as you can imagine, this is just fodder, because you are giving the public and potential litigants evidence that they would otherwise not have. It is a very, very, very invasive thing. Then, of course, there's the insurer investigation. Loss adjusters get involved. There's always a need for experts. There is the potential NEMA, environmental investigation for environmental degradation. And then, of course, there is the potential civil liability, being sued for damages and contract or delict. So it is, as you've just seen, it is huge. The environmental liability alone for a collapse or a terrible casualty on site can outweigh the cost of the damage done. So, for example, we have a massive claim in Durban where there was a fire, and the environmental degradation claim and the potential litigation coming through may well come close to about 800 million rand. And as I say, you know, it's not getting sued because a fire has happened and people have lost their lives on a construction site. It's what happens after that now is becoming even more frightening. Okay, professional responsibilities. So the construction regulations under the Occupational Health and Safety Act require written appointments for designer and contractor. And then, of course, the designer of the structure has a duty to design a safe structure and carry out inspections and issue a certificate of completion. That written contract, of course, set up the scope of the mandate, design, supervision, those types of things. And every professional body has a code of conduct. And of course, remember, the engineers, architects, quantity surveyors all have their own Professions Act. They all have their own conduct. And that's what the EXA investigation or the professional body investigation will focus on when, sadly, tragedies happen on site. My time is short, so I'll skip past the building regulations. In summary, what the building regulations say is if you're going to build it, there's going to be a factor of safety. You've got to build it adequately, and you've got to take not only engineering elements into consideration, but also things like public safety and danger and risks to the public. And then, of course, potential claims that could happen from a collapse on site are employee injury, death claims, death of loss support, third-party injury, death, loss of support, damage to surrounding property, movables, loss of plant, material, equipment. That can be huge. So think about Martin's first example. Let's say that had collapsed. All of that scaffolding would have been underneath in the rubble. If they've hired that in, that'll be a complete loss. That's a loss of temporary works. Cost of reinstatement if destroyed or damaged, pure economic loss. Environmental has a massive quantum. And then, of course, this excludes all of the trials that happen, investigations that happen. And that's, so for example, media by trial, professional misconduct inquiry, the occupational health and safety public inquiry, site closures pending the Section 31 investigation, criminal charges, NEMA and the Occupational Health and Safety Act, civil litigation, and of course, the insurance litigation. I know we are running out of time and there are a few questions. So Adrian, for example, you've raised your hand. I don't know if you want to pop your question now. I can't hear Adrian. I don't know. So Adrian asked about duration. So I can't hear Adrian for some reason. I don't know if we've been put on mute or so. The duration, Adrian, that's a good question. So for example, the Section 31s can take, sure, what's my fastest Section 31? I think my fastest I've seen the Department of Labor close out a Section 31 is around about 10 weeks. That's just the preliminary investigation. The Section 32 investigation, I've seen them take up to 5 years. That's the inquiry. So the insurer is in for a very long ride. That's why the Section 31, it is so critical that you get on that as quickly as you can, because as you can imagine, it happens on day one. You've got to be there for the Section 31, and the Department of Labor will traditionally shut the site so they can investigate, and you've got to be there to help your insured out if they've got that cover under your policy. And the Section 31, literally, as a construction lawyer that helps with these investigations, you fly out immediately, you walk into site immediately, and you are there all the time. You don't, you have to be there all the time. And it's critically important that you're there all the time. And that Section 31 can take, a very quick one, I would say 2 months. And then a Section 32, which is the formal public inquiry, it can take up to 5 years. I think Inyaka Dam took a number of years. I know Greyston Drive took 2.5. And yes, recommendations. I see Nadia's asked if prosecutions have been recommended. Prosecutions have been recommended. I know that it is with the NPA, but I don't do the criminal side of law, thank goodness. So I don't know what happens after that, sadly. I try desperately to stay away from criminal law. It's not something that interests me or excites me. So I know some of you only have 1 hour, so I'll probably try and wrap this up in the next 5 minutes. Ricardo, I know you have your hand up, but for some reason I can't hear people that are speaking. Ricardo, do you want to maybe ask a question?
Hi, David. It's Shushi again. So the one question we have is from, let me just see. Give me a second. Okay, we're just filtering through the questions.
So I see Ricardo's got a question. If a developer appoints a contractor to construct or erect, say, a commercial building, okay? So the contractor has CIR cover. Is it necessary for the developer to arrange PL cover in case legal is taken against both? So it would always be a very good, very, very good thing if a developer and a contractor, especially in a greenfields project for a new construction, if they have a proper construction contract concluded between them, and then remember that contract will set out, so for example, a proper GCC contract with proper contract data, it will set out who's designing, it will set out who takes on responsibility, who's insuring, and that contract will dictate all of those things. If that contract is comprehensive, depending on who has design responsibility, it will dictate who should take out the insurance and who should be liable. So for example, if the employer is designing, the employer will appoint their own engineer. Then the employer or that engineer will take out that cover. If the contractor is designing, then it should be a term of that contract that the contractor take out that cover with the design and any design failures. Dominic, your answer, whilst in construction stage, what are the requirements of those on site? So interestingly, you asked that. Construction regulations were promulgated under the Occupational Health and Safety Act in 2014, but nobody reads them, like stop signs written on the road. They dictate all of the appointments that have to be made, and they dictate that the people appointed in terms of regulations have to be competent. And competence is determined in terms of those regulations per category. So you can't just appoint someone off the street. They've actually got to be competent, and they've got to show they are competent. So qualifications, you can be qualified in various different ways, but you've got to comply with the Occupational Health and Safety Act and the construction regulations with regards to the competence of each appointment. Section 8, Section 16, you've got to be satisfied that they are competent, and you tick that box under the Act. Someone who checks that they are working 100%. So that's the difference between supervision and inspection. And the person who designed the works that are being constructed ought to be supervising or inspecting, because remember, they've got to sign the cert at the end of the day that says, yes, this has been constructed to my design. So that is the short and the quick answer. Okay, so I will.
David, there's one other question. Following a health and safety inquiry, if the department recommends prosecution, are these criminal matters taken further? Do they ever progress further?
So I answered that one off the bat because I read it first. So yes, apparently they are. They've all recommended prosecution. I don't know what's happening on those ends because remember, I'm not a criminal lawyer. So the second that goes into prosecution, and that's where I step out. So I believe they have recommended prosecution. I believe the NPA, the National Prosecuting Authority, has taken it up, but I don't know what the outcomes are. Remember, is a CEO of a large construction company going to get put in jail where there is a design flaw? Probably not. They're probably going to receive a massive fine, and we're all going to move on. That's the reality of it. So the Mayorsdale eco-estate collapse, this is a collapse up here. Sadly, workers were killed. It's terrible. The collapse occurred in 2014. It's a house, believe it or not, that massive structure. There were internal renovations taking place. The Department of Labour held a public inquiry. So 7 construction workers died on site. And there, the contractor was held liable. So was the employer, because who was responsible for the design. Okay, and test for negligence. There is the standard test in Kruger versus Kutsia. However, the test for negligence is modified for engineers and architects, and it determines what their duty of care is. And the mayor's case in the Supreme Court of Appeal in 2020 is a great example of that, and that's what the court held. I know the talk's over, so I'll just shoot through. And of course, remember, our test for negligence in the construction industry at professionals differs. You could look at the engineer, and it's the duty of care bestowed upon architects, engineers by the virtue of their professional skills, knowing what they knew at the time. And it's an engineer of similar professional standing, what they would have done, knowing what they knew. And then, of course, you could look at Labuschagne versus Tehran, and you've got to look at you're not required to be perfect, and that's what people forget in the engineering world. You're actually allowed, and I don't want to say allowed to make a mistake, and this goes back to 1914, believe it or not, but there has to be a high level of degree and skill knowledge, but it's also reasonable. It's got to be a reasonable skill and reasonable care in the circumstances, and attendant upon the engineer's level of skill and expertise. And then it's very similar to medical negligence. I will share my slides with the team at iTOO, and I'm sure they will then share it with whoever wants them. But yeah, I know the time is up. I'm sorry. As I said, I normally speak for hours on this. But yeah, I will share my slides with the team at iTOO. I have it ready. So Shushi must just feel, free to share them with whoever needs them.
Thank you, David. Very
Thanks,
insightful,
David.
interesting. I know you can go on. You're so passionate about the construction industry. Thank you for your time. Martin, do you mind putting on your camera so everyone can see you to stay?
Oh, my camera's been on the whole time. I'm definitely no model. So whenever I have my camera on during a talk, I think to myself, Shane, some people can see the talk, some people can see my face. So I try and be slightly animated during my talks to try and keep, you know, some encouragement going. Sometimes these can be a bit boring.
No, not at all. We found it very interesting,
Cool.
especially for me that's now entered into the PI space. So, I mean, you broke it down. So, yeah, I enjoyed it.
And thank you to Martin, who's always someone I willingly drag into talks with me because we're in the same space. A massive thank you to Martin for always giving up his time. You know, it's sincerely appreciated.
Martin,
Thanks, David. Oh, sorry. I just wanted to say thanks, David, for that. I'm in the underwriting space, and you know, we are now also starting to kind of inquire about the contracting side because it is starting to impact our policies. And so I'm very interested in, you know, chatting further about this topic because yeah, it's critical in our space as well.
Well, I lecture the construction industry on the contracts.
Okay.
So I can take you back to 1999 when we decided to only have 4 of them in our country, and I can show you how it's developed from there. So anytime.
Perfect. I would love
anytime.
Right.
Cool.
Thank you, guys. Thank you for joining us to the attendees. Thanks, Fiso, David, Martin.
Absolute
We
pleasure.
look forward to the next PI session.
Yes,
Awesome.
definitely.
Anytime. Thank you, everyone.
Thank you.
All right.
Thank you, everyone.
Cheers,
Thanks.
guys.
Bye,
Bye.
Martin. Bye, David. Thank you. Bye. Bye, everyone.
Bye.